Hey guys, so you're not infant alcohol. Today we have noodles and company. I got sketty.
Ew. I got zoodles.
So what did you do today, Kayla?
Well, I ran to King Soopers and I ran out. But guess what? I got lost in King Soopers because they like rearranged a lot of stuff and I haven't been there in a while.
Yeah.
And I couldn't find the Chips Ahoy. So,
I think they're like for the ice cream.
yeah, that's where I thought, but I didn't want to go there. So I got these sugar cookies. And I think my son took like 10. So, he said the rest were for his siblings. But we'll see. Oh, you can't even say it. Do it again.
That's Chris.
It's gonna be like I'm gonna throw up.
Did you?
Kelly was like, "You made it in time," and I was like, "It's 1:07." He was like, "I'm giving you guys a window because it's snowy," and I was like,
No, I don't think she did. She didn't say anything.
"Yeah, she probably."
I don't think croc.
I think croquet. I don't think he knows. Yeah.
There's 8 other people here. And by the loudest. 10. There's 10 other people here, but we're the loudest.
Okay, let's see. Chris and Chris, the only 2 people who haven't taken the summative yet.
Chris didn't take the summative twice.
We are going to
Kind of
go
looks an
over
appetizer.
your summative assessment first from Friday. A few points about what's in the grade book, and then we have a video, at least part of a video today to look at, which is an interesting start to a summary of the history of surgery, which is something that I hope we can draw from to learn more about the biochemistry of modern medicine, which is where we're headed now. But let's start by reviewing your summative from last week. Chris, if you could step out. Thank you. So I closed out the end grade component. You can take a look at that
That's
now
Chris
if you'd like.
leaving. That's kind of cheat. These meatballs are good.
This brownie tastes like brownie batter. Dude, I literally look like I got caught in a tornado. My friend Francisco's ears are bleeding.
Yeah, he went to a concert, and then now his ears are bleeding. Thank you. I got a 36 out of 40. Really bad on my sketty. Oh, dang.
Oh shit, then I got it really wrong.
Oh, heck. -2, I think.
Oh, heck.
That's the only place I lost points. Heck. Oh, I got sketty all over it now.
I did.
Never mind.
I put nonsense, but then he didn't understand.
I got 5 meatballs. I've eaten 2. This is the last part of my 3rd one. They're delicious.
Mine had mushrooms, and I didn't think I liked mushrooms, but I ate it, and it was okay, I think.
The bottom of my sketty didn't have any sauce, so I put in the rest of the sauce from the
True.
garlic bread.
Yeah, the marinara sauce from the garlic bread. Thank you. Aw, dog.
Everyone here get one.
Mm.
Okay.
There's a lot of sketty. I should have gotten a smaller one.
Alright, so
What?
take a look at the end. I'm going to give you
I
some
don't
time
eat them
to
that
scan
often.
through
I
the
just
end grade
realized that I never
component
really
and the
ever
short
finish
answer
it.
component, and then we'll go over it.
Probably should have said this one. Okay. I got these wrong. I got 4 of them wrong. Disgusting.
While we were taking the test, she looked over at mine and was like, fuck. And I was like, me too, dog. I got them wrong too.
Yeah, but yeah, and then I did this one also wrong. So I got the same questions wrong, but I got more wrong than she did.
Overall, we made our senior pages today. All in all.
Oh, yeah.
Is it open?
I've heard of it. Yeah.
Closed. Get the question.
So I got.
Should I just screenshot all of them?
Yeah.
So,
Sketty.
I'm just gonna screenshot the ones that I think are the hardest.
I did the squared thing and I got that.
I also have another long video on my phone. I don't know what it is, but I'm too lazy to upload it because it takes a solid 2 hours.
In this class or?
I don't know. Because I know we have the choir one,
right.
but I don't think I want to post that one because
Let's take a look at the multiple choice part first. There's still a few people yet to take it, including 2 people in this class. Some are taking it after school, so I don't have a final average. The average is better, certainly, than where we were at the formatives, which is great. Very much like with the final exam. The final exam was intentionally, some questions were repeated from summatives. This summative has some intentional repeated questions from formatives that were, I think, people wanted a second chance at. The rest were really similar, but reworded, or the question was focused in a slightly different way. I think a lot of folks benefited from having a second go-round at it. So here's 1, 2, and 3.
This entire side of my face.
Any questions on 1, 2, or 3? Okay. 1 was a repeat. 2, the question about the 2' carbon alcohol group. Just focus more on what actually makes it unique, why that matters. And then purines complementing with pyrimidines. That's 2 ring with 1 ring is what keeps it a constant width. How about 4, 5, 6? Four was a repeat. 5 was asked a little bit differently. I asked you about 2 hydrogen bonds instead of 3. And then number 6 was also repeat, trying to emphasize that DNA polymerase only reads the template strand in one direction, therefore strands can only be built in the other direction. Seven, 8, 9. Seven was a repeat that the template strand always determines what the sequence of nucleotides will be in the new strand. The primary difference between leading and lagging strand is that the leading strand is synthesized towards the fork, lagging in the opposite direction. B has them flipped, that leading strand is continuous, lagging strand is in fragments, and then this part here needs an RNA primer or doesn't. actually both strands need RNA primers. There's no difference in that aspect of it. The order of PCR events is denaturing, annealing, and replication. Replication, sometimes the word is extension or elongation, but it all means the same thing. Number 10, so when it came to calculating a number of strands of DNA, last time I actually asked you to calculate it. This time I just wanted you to focus on what the formula means, that if it doubles every time, that you don't take 2 times the number of cycles, it's 2 raised to the power of the number of cycles. So the actual answer is 2 to the 6th power, not 2 times 6. How about 11, 12, 13? Okay. 14 is asking about the modifications or the RNA processing. These 3 things have to happen. I didn't talk about alternative splicing at all, but these essentials have to happen. A cap on one end, a tail on the other, and then removal of the introns. Number 17, this is something we discussed on many occasions, that a single protein can actually impact many traits in an organism. 19, a definition of tRNA. 20 is a repeat. 21 is asking you to come at it from a slightly different way. Last time, degenerate was the answer. This time, degenerate, I'm asking you to give me the definition for degenerate. This is an important concept in 22. I just want to make sure that we all understand it leaving here. In that, if an adult, not only if a mutation happens does it matter, but it matters where and when it happens. It has to happen in DNA that makes a difference for the organism as opposed to junk DNA. It has to happen in a cell that is going to affect function down the road. And when it comes to passing down to their offspring, the mutation has to be somewhere in a cell that will actually be used to pass to the next generation. An adult brain cell would not do that, so that's false. 23, that's the definition, pretty much a description of CRISPR-Cas9, an RNA guide molecule bound to a protein that can cut or mutate DNA. And then a matching section about mutation, which is kind of all the same, mostly the same answers as the second formative, just in a matching style instead of putting X's in the table. Any questions on the end grade portion? Okay, let me pull up the free response section. Do that. So, here it is in color, and I wanted to find a diagram that you could still use if it was in black and white. And the one that printed, I think, still pretty well shows what all the pieces are. It's sort of cartoonish enough that you can pick it apart. Excuse me. So, first, H and I don't have like arrows or brackets or anything. They're describing this strand versus this strand. So I is the leading strand, H is the lagging strand. A is right at the replication fork. That should be either helicase or topoisomerase. Topoisomerase is not in your list of options, so helicase is the best answer there. And then these kind of weird oddballs here that are stuck to the individual strands, they most align with single-strand binding proteins, the things that keep the strands from coming back together. Now, the rest of everything, that is C through G, you do need to kind of use clues in the picture to figure out what the best answer is for all of them. Sometimes process of elimination is the only way to get there. But one thing I think you can pick apart right away is all the squares, the things labeled C. They're all at the end of new DNA. So the implication there then is that this is DNA polymerase 3. It's what is actually synthesizing new DNA. You can cross that off your list. F has got this whole bracket covered. So it's talking about this entire segment. So the best answer there is the Okazaki fragment, because that's the whole thing. And that helps you a lot with E, because you can see that there's different colors here. This is different from this. All new segments of DNA must be started with an RNA primer, so it makes the most sense that this piece right here is an RNA primer. Okay, and that leaves us really with D over there, the hexagon, and G at this end. So the one clue that helps you is where it's located. Here it's at the end of a new piece of DNA, right in this gap. Here it's at the beginning of a new piece of DNA. So this makes the most sense then to be primase, that it's laying down a new piece of primer before starting a new piece of DNA. And then this makes the most sense for what's left, which happens to be DNA polymerase 1. But it also makes sense because it's at the gap where two fragments are coming together, and this primer is still there. The job of polymerase 1 is to eliminate that primer and fill in the last bases. Okay? So it makes sense that that would be present there as opposed to ligase, but ligase isn't on your list anyway, so I wouldn't include it. Any questions on that sort of process of elimination to get to that place? Okay, so the correct order is C, D, G, E, I, H, A, E, F. B is, I took a lot of different ways of saying this, but unwinding, preventing knotting. It prevents the DNA from knotting up and tangling while it's being unwound. And then C, the answer is ligase. You can be taking notes on this since it's already graded. You don't have to, you don't have to keep your hands off. Okay, for A, 2A. So this is the second shot at these math questions, and I started it exactly the same way as the formative in an effort to give you a chance to come at it the same way. It says 14% of the population is lacking muscle. And it says that those 14% have to be homozygous recessive. So they have two of the same allele. They have two recessive alleles in order to have this. And you can actually figure out if you have this too. Take your hand, take your fourth finger, cross it over to touch the base of your thumb. Okay, so your ring finger touches the base of your thumb, and then bend your wrist this way. And if you see, it works better actually without your hand up like this, but bend it towards you. And if you have this prominent tendon that pops out right in the middle of your wrist, that means you have the palmaris longus muscle. If it's missing, yeah, so ring finger across to the base of your thumb, okay, and then lift your wrist towards you like this. Some people have a very prominent, like right down the middle. Okay. Well, so there are kind of two there, but it's a very prominent flat one that's right dead center. Okay. And some people actually have it on one hand but not the other. So you can actually see it in one location, not the other. Yeah. So it was thought that muscle was really important for grip strength, but not once thumbs
That's like
developed
milking a cow.
and where it became opposable like this, then
That's a lot of
the
skin.
grip strength that this muscle gives you is not any significant amount extra. It's more important if there's no thumb present.
Yeah.
If the thumb is present, then this grip is enhanced by having that palmaris longus, and you can actually see it start to engage, right? So it doesn't confer anybody any extra advantage in any way. But it's really interesting to kind of trace when and how that trait starts to fade away in certain populations. Okay, so again, we're in the same place we were when we did the formative, the formative on this, and that is, this is not an allele frequency yet. It is describing the percentage of people that have the trait, not the percentage of all alleles for that trait. So we have to go to this and recognize again that these terms mean something. Homozygous for P, homozygous for Q, heterozygous in the middle. these individuals are homozygous for a trait. You can pick one or the other. I often like to use dominant here, recessive, just to have, put dominant first, recessive second. So that means that 0.14 is equal to Q squared, because that's the fraction of the population that has both traits. Then we solve for Q by taking the square root of both sides, and you get about 0.37. And that's the frequency of alleles, okay? So of all the alleles in all of the room here, about 37% of them are for not having the muscle. The remainder, which is the answer to part B, is those who do have the muscle. So P plus Q equals 1. And if Q equals 0.37, then P equals 0.63. And that's the answer to part B. Okay. So of all the alleles, of all the humans out there, there only has 2 of them. 37% of them are for not having the muscle, 63% of them are for having the muscle. C. Now we get to use those numbers in a meaningful way. We can go back to this equation, recognize what the parts mean. If you're homozygous for the trait, that's P squared, which is 0.63 squared, and that comes out to about 0.4. So 40% of the population is homozygous for the trait. And then D is the heterozygotes, 2PQ, so that's 2 times 0.37 times 0.63, and that's about 0.5. So half the population is heterozygote. Now, you'll notice if you add these up, these should all add up to 1. 0.5, 0.4, and 0.14 do not add up to 1. It all has to do with how many numbers you keep in your calculator. If you do this out, you get a very long decimal. It's like 0.374, blah, 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 blah. If you hang on to all those decimals and continue doing the calculation, you do get numbers that add up to 1. This ends up being like 0.262, or 0.626, sorry. This is like 0.39 something, this is 0.47. It does work out if you hang on to enough data. And then for part E, migration, natural selection, mutation, genetic drift, those are all possibilities we listed. The most important thing for me, though, always, is you must address the question directly. It's just describe a scenario. If you just say mutation, if you just say natural selection, that gets you 2 points out of 3, but it doesn't describe a scenario where natural selection causes a change. Right? We'll see that same problem on the next question. Any questions about this? This is going to be a short answer on the chemistry final. I think we need to keep hitting it. Absolutely. Okay, and then for 3. I don't know if I need to write anything, but I'm very confident everyone can do a transcription and read that table. I think that's a skill you learned last year, can continue to do it. I'm glad. Identifying mutations, generally okay. Point mutation for 3B. Anytime one letter changes to another, that's a point type mutation. When it says show how this mutation alters or doesn't alter, there are lots of ways you can show this. One, a lot of you just wrote out, here's what happens. That's fine. Using a diagrammatic method is also great. This is the original sequence. You can show that that sequence in the gene has been altered by mutation, which then becomes this in the transcription, and it produces a stop codon. That's actually a fine way to show me, too. It demonstrates how the information has changed in a very diagrammatic way. By definition, if a stop codon is introduced early, that is a nonsense mutation. That's the answer to D, nonsense. And then in terms of what happens for part E, okay, again, you can get 2 points out of 3 for saying this protein is shorter than it should be, which is true. It gets truncated. That's the official term. But you have to say something about how the protein's function has been altered, and in other words, how it works. And I took anything really as Luz is saying that it doesn't work as well, which is probably true. But if a protein is cut completely short like that, it probably doesn't work at all. So that's the best answer. Any questions about the short answer part or the end grade part? Okay, I'll take back the short answer. If you have in your grade book an IC anywhere, that your test score is marked incomplete for any reason, there should be a note as to why that is. Actually, not many folks have that in this class, now that I look. What it was supposed to mean is that I don't have one of your free response sections for corrections, but I don't think anyone here has that problem right now. If you look in the IC right now, if you see anything that's marked missing, especially under corrections, all that means is that you may not have been able to finish your corrections before handing it back to me for the formative. You will be able to finish it. I'm not cutting you off. But today's not the time to do that. But you will get a chance to do that. As for corrections for this, we do summative corrections just before the final exam, the week before the final exam, because it's supposed to be sort of a stepwise process. A formative is supposed to prepare you for a summative, and we do corrections prior to the summative. Summative is supposed to prepare you for the final. We do corrections on the summative prior to the final, so the preparation. Okay. Given that there's only really 2 units in this trimester, this and the one we're doing now over the next 3 weeks, expect this summative, the material on here and this stuff, to make up more than half of your final exam. Okay? Very good.
So my corrections were missing, but I turned out mine's missing too. Does Chris get to come back?
Yeah, I'm going to get him.
Oh.
Yeah, what's up?
Wait, are you going easy?
Soon.
Okay, never mind.
Okay,
That's
deal.
actually later.
Okay. We'll just get rid of this stuff and actually, do you want to go get Chris?
Okay.
Yes.
Hey guys, so right now I'm getting Chris. Chris!
Huh?
Come on!
All right.
I got Chris.
So are you finished?
And her too, right?
Yes. Oops. Yes. Okay guys, so
Is there
I
anyone
got
else
Chris.
who had their formative 2 corrections marked missing, but
No.
actually turned them in and was
Chris.
complete with them, finished with them? Fernando, hi. And Karen and Kayla, anyone else?
Okay, it seems like it's gonna be the end of